So it's first to build various configurations and then to perform the test cases so that you stress it until failure. So you're really hitting this configuration hard. You're really getting the right people that really know how to go in and test this configuration. So as an additional scenario, just to get your cake and eat it too, you may actually want to look at the performance of that particular scenario. Okay? So we're looking at, did it work, and then we might look at how fast it did something. So now we could look at it from a design of experiment point of view, or I got another approach I call DOE, Collective Response Capability Assessment, DCRCA. So that would another thing that you might be able to do. So then the percentage coverage for the test would be similar to that shown in the previous example that we talked about. If we, that we came up with. Because in this case we had 8 trials. We got the combination of 3, 2, and 1, and so forth. And if that all worked, then you'd feel comfortable about buying the software and making that change, or about buying the computer. Now the question I'm asking, if we went in and ran this particular matrix, would this particular test capture this problem? I'm just making a statement that when A is -1, that's printer X, and you got 2 displays in network X. That would be A is -1, B is plus, and G is a -1. Would this test configuration capture that? This is a test.
Yes.
Yes. Right. So that one would fail, right? Now, when that one failed and the other ones passed, would you know why it failed? No. It could fail for a lot of reasons, right? But you did your job as the test organization. Your job is to see if there's going to be problems when you get out in the field. So the program was written here so that a computer terminal could interface with a link that is attached to a computer network. Another example. A structured test strategy was looking at these combinational problems like we've been talking about. We wanted to see if we got combinational problems. And then, again, what we're trying to find is, does these things work together or not? That's what we're trying to do. So these assumptions were made. We're going to use that design matrix in the tables that we have from Six Sigma. And we're looking at the 2 extremes. Also, if we look at abnormal situations, the trial would be reassessed without an abnormal situation. So this is an example of what you could come up with. So you're sending data, large amount of data, saw, receive data, and so on. So this kind of describes a software scenario that you can run through. Now notice here what I've also done here, just to give you a little bit of clue where I'm going, is I can actually look at more than 2 levels. So I can actually look at, in this case, 4 levels. So what I'm going to be doing is combining 2 columns, minus, 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 plus, plus, minus, plus, plus. So I can actually look at 4 levels. Now, my test coverage that I was showing you in table below is not going to be exactly right when I do that. But I can actually, still address more than 2 level situations. So I basically come out with this particular scenario. So that would be my design. In this case, I needed to run 16 trials. Because if you start looking at the number of factors and levels, it's beyond 7. So if I'm doing 7, I can do it in 8 trials. But if I get to be 9, I have to move up to 16 trials. So in this case here, then I would go up and look at this over in 3 factors. I'm on the blue here. So I come up and over on 98% coverage. So I got 98% coverage of the 3-factor combinations. Okay? Now, if you look at what really happens in the real world at think in many organizations anyway, there tends to be walls between the development and test organization and the manufacturer. What I'm suggesting with this approach, you can go in and start breaking down the walls. So now you get everybody together to go in and figure out the factors and levels that you're going to be looking at. So now you get a coordinated system on how we do it, because there's some people that understands where we ought to be focusing our efforts. So it's a systematic approach on trying to do that. Now, the other thing that you can do, I apply this mostly in the system tests. I did like at IBM and Dell and so on. But the thing is, you can also go in and do this in a hierarchical fashion. So if you're developing code, you can go in and start, start down here, where now you're looking at various sections of the code. And so now you can build your factorial matrices to make sure that it works by themselves, as opposed to waiting to the end, then you find out, well, way down over here, I got a problem. So you can run these factorial matrices in portions of your system. And then you start putting those together and start building it up to the overall system test. So that's another way of approaching it systematically, on how you can put it all together. So the opportunities for doing this is like system configurations. You can do it for like microcode, software. The other thing you can do is, why does one system work and another one doesn't work? So you can take and start switching parts around. Say you got 5 or 6 different things, and you start switching things around and find out, why doesn't this work? Oh, it's a combination of this and that and the other, and that can give you insight to what the fundamental problem might be in your design. And also dealing with intermittent failure diagnostics. So if you got something that doesn't work, again, you can start switching things around, start looking at how customers might use it, things like that, to identify when you've got problems. So the traditional test often leads to inefficient one-at-a-time approaches, and we can miss combinational type problems. It also does not address coverage statements. So this DOE test matrix approach can systematically test these combinational problems, and also can be used to utilize team inputs to actually figure out what particular combinations of things you're going to do. And it can give you, like I said, the test coverage statements. Does not include coverage statements here. Okay, so now let's look at how you might deal with this if you got more than 2 levels, because this is a rather simplistic situation. So I'm going to show you a situation that's a lot more complicated. So, and this is a real situation. So if you okay, so what I got here now, the way this is written here, so this is a big experiment, okay? I'm just going to hand it over the top of this. Okay, so this is, way this is written here, this is the first factor, okay? Okay, and so this has 29 levels. That's, and then the, let me start here. Okay, so in this case what it's got is 15 factors. Okay, so this is factor 1. Okay, so this has got 8 levels.